problems from the puzzle worksheet, and this is the first one that we decided to go over. So the P stands for pi, and we're going to multiply straight across and reduce. So on top we have pi times 180 over pi, and what ends up happening is my pi's cancel and I'm left with 180 degrees.
That's it?
That's it. Yep. Any questions on that? No? Okay. Pretty straightforward.
Yeah.
For number 23, the same idea. So what would I multiply 23 by? Or 13 pi over 6?
By 180 over pi.
180 over pi. Can I cancel anything right off the bat?
The pi's.
Yes. So you can cancel the pi's. Okay. Ooh, I picked a bad color. Okay, so that's 13 times 180 and then divided by 6. Gonna get me a very large number on top. Yeah. And then just divide by 6. And so 390 degrees. I'm used to writing 360, so I automatically wanted to do that. Okay, 390 degrees. How about that one? Is that one okay? Okay, what about multiplying for the last one?
We do the same thing.
Whenever you convert from radians to degrees, this part, what you're multiplying by, does not change. It's always going to be 180 over pi.
And if it was like, if the pi was on the bottom, it would be pi times 180. Pi over 180.
Yeah, pi would always be in the numerator. If pi ended up being in the denominator, I don't think you'll have a problem like that, but I would keep it the same. If they tell you this is in radians, if it tells you that this is in radians and you're going 2 degrees, you always want your 180 to be on top and your radians to be, your pi to be on the bottom. So this part does not change. If you didn't have pi in the problem, then I would make sure and say, does it say that this is in radians and am I converting it to degrees? So I'll show you a couple where we're going backwards just because I didn't record those before. Again, the pi's cancel right off the bat. And then you do this multiplication and divide by 6. So I get 330 degrees. So if you guys want to give me a degree measure, I can tell you what, how to do it backwards. So think of any number.
Does it have to be a big number?
Nope.
6.
Okay, so 6 degrees. So 6 degrees, if I wanted to convert this from degrees to radians, you would multiply by what? So degrees is what I have on top. I want to get rid of degrees. So I put it on bottom, and you want pi on top. So whenever,
you would times it by 360 over.
not 360, I would multiply straight across and then see if I can reduce. But you should end up with fractions for these problems. So there's an invisible 1 underneath that 6. So when you multiply straight across, you get 6 pi over 180. And since it is a small number, sometimes they don't have a common factor, but in this case, they do.
So
I would
basically
go,
just getting rid of the degrees here.
yes, this one, we're getting rid of the degrees.
Okay.
So before the pi's canceled, in this case, the degrees are canceling.
Gotcha.
Mm-hmm. So I could reduce 6 and 180. I would try and reduce by the largest number possible if you think it's possible. And in this case, it is. So you're left with pi on top, and 180 divided by 6 is 30.
So how do we like find a common factor?
Look at the numbers and just try. Most of the time, so you're reducing by something that 180 has in common. So 180's factors, there are a lot of numbers. Again, I keep using this pen, but it's not a very good pen. It doesn't show up very well. This color will. So 180's factors are 2, 3. I don't think 4 is 1. I could be wrong. Oh, I was wrong. And 5. So if you can reduce by these numbers, these will help you. It's 2 and 90, 3 and 60, 4 and 45, and 5. No, I think I did that wrong. Oh no, I did that right. 5 and 36. And then 6 and 30. So these are your factors. So odds are you can divide 180 by anything because we didn't really skip anything. It's not divisible by 7 or 11, but like it's divisible by all these numbers and you can keep reducing. Does that help?
Yes.
Okay.
Yeah.
Do you want to try another one like this where we have degrees?
Yeah, sure.
Okay. So let's do another one with degrees. Try and think of a weird number. 150 degrees. So that's a nice one. That's actually a common degree because it's on the unit circle, which we deal with in other math classes. What would I multiply this by to convert it to radians?
Pi over 180.
Yes. So we want pi on top, and we want to get rid of the degrees.
Oh,
So
she said it before me. Dang it.
that's okay. So we're going to multiply across. I'm going to put 150 over 1. And we get the degrees cancel. So we get 150 pi over 180. Automatically, you can reduce by 10. So now we're left with easier to deal with numbers. Can you think of something that they have in common? They have 3 in common.
3.
Yeah. 15 divided by 3 is 5. Tag on the pi. And then 18 divided by 3 is 6. So that is 5 pi 6. We good? Okay.
Yes, we're good.
Okay, just making sure. Does anyone have any questions on how to get onto Edsby when it's working or uploading stuff? And is there any technological issues that we're having?
No.
Okay.
I don't have
Send
any.
it to you, like just a picture on.
Yeah, just send me a picture of this. You can send it in an Edsby message. You can send it to my Google number. There it is. Or you can attach it to the assignment itself, and I can click on it and view it. And that can just be a picture.
Oh, I see you had one example at the top. I didn't get that one. Can I get that one?
Yes. This one?
The before.
Oh, the stuff from before. This one.
Yeah, that one.
Okay. Yep, of
I'll
course.
just take a quick picture of it.
Yep, not a problem.
Okay, I got it.
Okay, well, I think if there's nothing else, I'm going to end it early. Are we all good?
Yeah, I'm fine. I'm straight.
Okay, awesome.
Instagram.
Let me know if you have any questions, okay?